Over the last few decades, international climate treaties have encouraged governments to reduce global greenhouse gases. The passing of the Climate Change Act in 2008 saw the UK become the first nation to set out in law targets to reduce carbon emissions. A number of scenarios through which these emission reduction targets can be met have often encouraged an increase in the penetration of distributed generation. Community energy projects are a great form of distributed generation, but unfortunately they come across a lot of hurdles. This is usually because communities don't know whether or not the project will be feasible. Our project aims to address this issue by producing a piece of software that has a number of inbuilt generation profiles for wind, solar, hydro and CHP, as well as the ability for them to scale demand profiles and run a number of simulations that most closely match their own environment, producing them with key performance indicators to make an informed decision on the feasibility of a project. The project was broken down into a number of areas: data collection, financial analysis and power analysis, which were then combined within one user interface. GRIDlab uses real data in all simulations. Electrical and heat networks were created through the study of energy infrastructure across the Scottish Isles, and relevant demand profiles were produced using national grid data. Generation profiles for the chosen community energy projects were created through the analysis of statistics from the British Atmospheric Data Centre. A number of profiles are available for the user to choose from to closely simulate their own community. The model is designed to be scalable and modular to suit as many communities as possible. Using the Energy Technologies Institute Infrastructure Cost Calculator tool, the capital costs and operation and maintenance costs for all projects were analysed. Figures were calculated through the development of a component list, which was then grouped into assemblies from which to build each project's financial study from. Projecting the net present value of each project over 50 years and stating CapEx, the payback period was determined. Using project costs alongside government incentives outlined by Ofgem, the cost of electricity per kilowatt hour over the project life was calculated. The introduction of distributed generation to the current energy infrastructure has a large impact on power flow through the system, and hence the capacity of the network must be examined. PowerWorld Simulator allowed an electrical model of the proposed infrastructure to be designed. Integration of this with MATLAB using SimAuto allowed dynamic modelling of the power system to be performed, giving information on security of supply and producing warnings when lines were overloaded. With the consumer in mind, GRIDlab is customisable across many aspects. Simulation of seasonal variation shows users the difference in both demand and generation throughout the year. A multitude of renewable generation profiles and the capability to scale domestic load profiles gives communities the basis to make informed decisions based on resources most similar to their own. A supply and demand curve shows the users the way in which demand is met through a combination of local generation and the grid supply. When local generation exceeds the community's demand, a storage indicator highlights how much energy would be available for communities to store for use during periods of low generation. To understand the financial impacts of implementing a project, a graph demonstrates the net present value of the project over time with the payback period marked. The cost of electricity over the whole period of the project is shown using a graded colour bar indicator. Similarly, the environmental impact of the project is shown through details of the carbon emissions using the government limit as a reference.